mapped I/O versus port mapped I/O. So to access the devices, our CPU needs a mechanism to access all the devices and to transmit the data between the devices and the memory. So we have two approaches. One is memory mapped I/O, another is I/O port mapped I/O. So in the memory mapped I/O, basically all the devices are mapped to the same memory address space in which our system memory, I mean to say RAM and ROM, are mapped. So for accessing the device which are memory mapped, CPU doesn't need any special instructions. It can use the same instruction which it uses to access any other memory available into the system. But to access all the devices in the memory mapped I/O, our system address bus has to decode all the system addresses, so which required extra hardware if you are mapping your memory mapped I/O. In the port mapped I/O, your devices are mapped to the different memory address space. To access these devices, CPU needs special instruction set to access these devices. Because your devices are mapped to the different address space, you don't need that much hardware decoding of the address spaces, because your device memory will be small as compared to the memory which you are going to access for the whole system RAM. So you don't need to decode whole memory addresses, you just need to decode the addresses which are used by your devices. So if you quickly understand the difference between memory mapped I/O and the port mapped I/O, devices are mapped to the same memory address space with ROM and ROM of the system. In the port mapped I/O, devices are mapped in different dedicated address space. Because you are decoding the whole system bus. In case of memory mapped I/O, hardware cost is high in memory mapped I/O, but hardware cost will be low in case of port based I/O. And in the memory mapped I/O, because devices are mapped to the same memory address space, you don't need any special instructions to access the devices. But in case of port mapped I/O, you need special instructions for accessing the devices.